Okay, this is lesson 6.5 notes over graphs of polar equations. And so this is a continuation of talking about that. Remember that polar equations have coordinates r and theta. So r is the distance from the origin to the point that we're given, and then theta is how many degrees you are from the polar axis. So it would look a little something like this. Let's say I have a point right here. So this would be the r, and then this is our theta here. How many degrees? We're going to talk about what a graph of a polar equation would look like, and we've got things that we need to look at for this. I'm actually going to go to the second page, and there's some parts to discuss on that. If you look down at the bottom of the second page, it talks about analyzing a graph. And we're going to talk about all of these things: the domain, the range, continuity, symmetry, boundedness, what a maximum minimum is, and our asymptotes. Symmetry is number 4, but it's actually the first thing we're going to discuss. So we're going to go back to the first page and talk about what it means for it to be to have symmetry or be symmetric. We've got 3 types of symmetry. We've got symmetry about the x-axis. We've got where it reflects across the x, up and down. We've got the y-axis, symmetry about the y-axis, where it's a reflection across the y-axis from left to right. And then the origin is, they call it point symmetry, and it's going around the origin, which is a point itself. Basically, if you can take a graph and rotate it 180 degrees and it's still the same picture, then it's going to have symmetry about the origin. And I have some pictures of that at the bottom of the page. Okay, so the first picture there at the bottom shows reflection or symmetry about the x-axis. It's actually this blue part here. That's the graph, and you can see it being reflected across the x there. And then we have one that's showing reflection across the y-axis from left to right. And then the third one is a reflection, or is symmetry, sorry, about the origin. And a trick for you would be to take your calculator and just turn the whole thing upside down. If it still is the same picture moving in the same direction, then it's symmetric about the origin. Now, a lot of times we can just look at a graphing calculator or just the graph that we've drawn by hand and tell whether it's symmetric about the x-axis, the y-axis, or the origin. But there are times when you can't really tell, and so we have some things that will help us out. We can use this test to see if it's symmetric about the x-axis, where we're going to replace the r and theta in the original equation with r and negative theta. And then when we do that replacement, we're going to simplify it, and when we simplify the whole thing, if it looks like the same equation that we started with, then it's symmetric about the x-axis. We have a similar test for the y-axis. We're going to take r and theta and we're going to replace it with negative r and negative theta. Again, you want to simplify and see if the outcome is the same as the original function. And then the third one, the test for our origin, we're going to take r and theta and replace it with negative r and theta. So we're only really changing the r there. Again, seeing if it's the same or not. If it's not, then it's not symmetric. Okay, so we're on the second page here in the first example, and we're going to test for symmetry. So we're going to actually do one of the symmetry tests. We have our original function, which is r equals 4 sine 3 theta, and we want to know if it's symmetric about the y-axis. And to do that, we're going to take r and theta and replace it with negative r and negative theta. Okay, so I'm going to try that. I've got r equals 4 sine of 3 theta. And we're going to start replacing. So now I'm going to have negative r equals 4 times the sine of 3 and negative theta. Okay, doing a little algebra. We've got negative r is 4 sine of negative 3 theta. So if you can remember back to your identities, which I know that was our favorite unit, this is an example of odd and even functions. And so one of those identities said this. It said sine, let's back up here, sine of negative theta is equal to negative sine theta. So that was one of our odd even function identities. So we're going to apply that to this equation. So instead of having negative 3 theta, that negative is going to come out in front of the 4. Negative r equals negative 4 sine of 3 theta. And then I'm going to come back and, since they're negative on both sides, I'm going to divide by negative 1. And that's going to leave me with r equals 4 sine of 3 theta, which is the same as the function that we began with. Right there. So that means that our function is symmetrical about the y-axis. All right, for the next part, we're going to talk about what it means to analyze a graph. So we have 7 things that we look at when we're analyzing the graph. The first one is the domain, and that's the set of all x values. And then the range is all the y values. Continuity means, is it continuous from beginning to end? And basically, are there no breaks in the equation? There aren't any holes, there aren't any asymptotes. It just when it starts, it keeps going until it finishes. So continuity implies it's really asking, are there any holes or asymptotes? Which that just means breaks in the function. Symmetry, it's asking about the symmetry that we talked about at the beginning. Is it symmetrical about the x-axis, the y-axis, the origin, or maybe none of the above? That's possible. Boundedness means, is there an upper limit, an upper or lower limit? Basically, it doesn't go on forever. There's a point where it reaches and it can't go any higher on our graph. Or vice versa, if it can't go any lower, then we say it's bounded. It's either bounded above at the top of the graph or bounded below at the bottom of the graph. If it keeps going on and on forever, like a line, then it's unbounded. It means there's no limit to what it can be. And then the max and min Those are the lowest or highest and lowest points. And we have asymptotes, if you'll remember, like we did when we had the tangent function. Asymptotes is where we have undefined points. So those are all the things that we're looking for when we're analyzing a graph. Okay, so for the next one, what we want to do is figure out what the maximum value is. So for the functions that we're going to do here with the polar equations, we're not going to worry about the minimum value, we're only going to worry about the maximum value. So we're going to look at two ways to graph our equation. So obviously we have r equals 2 plus 2 cosine theta. And in the first graph, we have a polar equation. Okay, we've taken it, we've put it on a polar coordinate system, and we've graphed it, and there's the picture. It's kind of hard to tell what the r is because we still have the x and y axis there, but the r is the distance from 0, 0, 0 that we are, okay, that all of those points are. So we have kind of a sneaky trick here. We're going to go to a rectangular coordinate system. And what we've done is we've replaced the r in the equation with a y, and we've replaced theta with x. So now we can look at it in terms of x and y coordinates. And basically what it does is takes our polar equation graph and stretches it out. Okay? It's like uncoiling a spring and we're stretching it out as far as we can. What that allows us to do is refer to the y-axis for our r, which r and y are equal here then. And you can see that the y has a maximum up here at the top of 4. So that means our maximum r must also be 4. So we say the max of r is 4. And that's how you do it. So you take your polar equation, you're going to write it in terms of x and y instead of theta and r, and graph it on a rectangular system. The sneaky part is making sure that you get it in the polar system and then go back to the function. I'm going to take a moment here and we're going to look at how to do this. So for the graph on the left, the one with the polar equation, we're going to go and we're going to graph it just to see what it looks like. So we go to mode, we're going to go down to function. Now that's a basic rectangular coordinate plane. We want to go over to polar coordinates. So we're going to go over there, make sure that your graphing calculator is in radian mode, and you're going to hit enter. And then you're going to quit out of that because you now should be in polar mode so that when we go to y equals, it should have all of those r's in it. And then we're going to put in our equation. 2 plus 2 cosine theta. And I'm going to graph. Actually, let's look at our window first. If I look at my window, I can see that theta's minimum is 0 and its maximum is 6.28. That's just 2 pi. So that's basically one rotation along the unit circle. And then we've got a reasonable maximum for x and for y. And that's just how much of the x-axis and the y-axis we see. But now we're ready to graph, and it should give us that picture. Now if you cannot see it very well, what you can do is go to the zoom button, and that is, you've got your y equals, your window, and then your zoom. And you're going to go down to number 2 and hit enter, and that's going to allow you to zoom out and see more. Now nothing's happened yet, you've got to hit enter a second time. Okay, so I can see the graph. Obviously I'm missing some of it, so to help you be able to see the whole thing, what I'm going to do is I'm going to go to Windows, and I want to see more obviously of the y-axis so that I'm seeing above and below, and I want to see more of the positive x-axis. So I'm going to change those in the window. So my minimum for the x is okay, but I want to see more of the max. I'm going to go out to 5 on that. And then for my minimum, I'm going to make it, I can still see quite a bit of it, but I'm going to just go out to -5, and max is +5. And graph, and hopefully I can see all of it now. I can. It looks a little bit different because on the picture in our notes and the graphing calculator, the y increments are closer together than the x increments are. And that's kind of messing with the picture a little bit. Okay, so let's graph the second equation in terms of x and y. So to do that, we're going to go to mode again, and we're going to go back to function mode. And that's out of the polar, so we're doing a rectangular coordinate system. And we're going to quit. And I'm going to go to y equals. So this time, instead of saying r equals, it should give me y equals. Remember, we're replacing the r with the y and the theta with x. So we've got 2 plus 2 cosine x this time. I'm going to check my window again. So I want to change my maximum minimum here a little bit to like maybe -5 and 5. That's fine to go -5. Just I like to make it the same for my x's and my y's. So -5 to 5 and -5 to 5, and then I'm going to graph. Okay, so what I have is just a cosine function, and I want to see what the maximum value is. If you use your trace button, you hit trace, you can see a flashing X there, and that allows you to go left and right. Okay, so we can move our X left, we can move it right. When it started out, it was actually already on that maximum point, and you can see it gives us y equals 4. Y is also our r, so that tells us it's equal to 4. So that's how you graph it and you go back and forth. Okay, on the next page we're actually going to graph those. So what I want to do is graph my equation. I've got r equals 3 cosine 2 theta. And 0 to 2 pi, that just means we're going to put it all in the unit circle. And we want the max value for r. So I'm going to graph the polar equation and just see what that looks like. And we'll put it on our polar coordinate plane. So I'm back to my graphing calculator. I'm going to go to y equals. I'm going to clear that out. Now I'm going to do polar coordinate first. So I'm going to go back to change to the polar function. And I'm going to quit out of that. I'm going to clear the polar graph, and I'm going to type the equation in 3 cosine 2 theta. And I'm going to graph it. So we got a little flower there. What I want to do, obviously I've got right in the center at the origin, so I'm going to have a point there. And I just want to look at some of my other points. I'm going to hit the trace button, and I'm going to see that along the x-axis it goes out to 3. And along the y-axis it goes down to -3. And on the negative x-axis it goes to -3. You can see a trend here. And positive y, it goes up to +3. So to graph that, I just want to put those points on my graph. So I want a point there at the origin. I'm going to go 1, 2, 3 on the positive x, or the 0. On the 90, I'm going to go up 3, -3, down 3. Not perfect, but you get the idea. It should look similar to what we had. Okay? Looks like a bad balloon animal. Then we're going to go and we're going to graph the rectangular system. So I'm going to go back to mode, and this time I'm going to go to function mode, and that's my rectangular mode. And I go to y equals, and I'm going to replace the r with a y and the theta with an x. So I've got 3 cosine 2x. And I'm going to graph that, see what it looks like here. Oh, it's beautiful. Okay, and then I might take my trace button and I'm going to see if I can find that maximum value. It's very sneaky, but it obviously came right on that max value. If we cursored over and we went to the other top of the other little hump there, it should also be at about 3. If we rounded, that'd be about 3. So I would say that the maximum value there is 3. So over on the coordinate plane, we graphed y equals 3 cosine 2x, and when we plotted those, it looked a little something like this. Really bad, but anyway, you get the idea. And so here was our max value, and so y was 3, so that means our r is also 3. And that's our max. For the last page, example 4, we're going to graph our curve. It's called a rose curve because it's going to look like a flower, okay? And it says r equals 3 sine of 4 theta. And then we're going to go through after we graph it and we want to analyze the graph. So we're going to answer questions about the domain, the range, the continuity, the symmetry, the boundedness, the maximum value, and then the asymptotes if there are any. Okay, I've made sure to put my calculator in polar mode, and I want to put my equation in. So I've got r equals 3 sine of 4 theta. And I'm going to graph it. Okay, you can see we have a lovely flower there. So now, based on what my graph looks like, I'm going to answer some questions about the domain and range and continuity and so forth. First thing I think I'm going to do, though, I'm going to skip the domain and range for a minute and look at continuity. So continuity means from the beginning, when the graph started drawing, to the end, are there any holes in the graph? Did it skip anything? And actually, no, we just made the flower, the little ovals from the center to the edge and back, and so it was continuous. There weren't any holes, there aren't any asymptotes, so we just say it's continuous. And then we want to look at the symmetry. On this, you can probably look and tell that it's symmetrical about the x-axis, the y-axis, and then if we looked at the origin, you should be able to see that if you rotated 180 degrees, here you just turned your calculator upside down, it should look like the same picture. So it actually has symmetry about all 3. So for symmetry, I'm going to say x-axis, yeah, list them all. Y-axis and origin. For boundedness, means is there a limit, is there an upper limit or a lower limit? Well, we can see, like this would be my upper limit. There aren't any points for my flower that are above that green line. The same thing at the bottom, there aren't any below. So what we say is that it's bounded. Okay, and then for the max and min, that's when we kind of have to get a little bit sneaky, and we're going to graph it in the rectangular coordinate system. Now when I change my coordinate plane, my old responses are going to erase, but you can always rewind. Okay, so I'm ready to input my equation. Again, I'm going to change the r to a y and theta to x. So 3 sine x. And I'm going to go ahead and graph that. Okay, so basically we have the sine function there. And what that tells me about the domain and the range, the domain are the set of all x values. So if I'm looking along the x-axis, this is a sine function, so it keeps going forever and ever in both directions. So how we write that is we say it goes from negative infinity to infinity. So that's interval notation. That's also the same as all real numbers. Now the range is a little bit different. The range is the lowest point to the highest point. Okay, so I'm gonna use my trace button to identify that, which is also going to represent my max and min. I'm really only concerned about the maximum value though right now. So you go to trace, and right now it's in the middle right on the origin. But if we go over, we can see that the maximum value, looks like it says y is 2.99, so that's about 3. And then we're going to go over to the low point, our minimum value, and it says y is negative 2.99, so another negative 3. So that would make our range from negative 3 to 3. And so how we do that in interval notation is we make a little box from negative 3 to 3. So we know it's continuous. We talked about its symmetry. Its maximum value is just the highest point of its range, which is 3. And since it was continuous, it didn't have any breaks or anything, so it couldn't possibly have any asymptotes. All right, so when you do, the last 3 problems in the assignment do ask you to analyze the graph. And so that means you've got to answer all 7 parts, just like we have here. Okay? All right, I'm going to take a look at, I'm going to open up the homework assignment here real quick, just so we can talk about that, and then I will see you on Thursday. All right, so for number 1, it has 2 parts. It wants you to do 2 things here. It wants you to complete the table. All this is input and output. So, for instance, for pi over 4, you're going to put pi over 4 into the equation. Say 3 cosine of 2 pi over 4. You're not graphing it. You're not in graph mode. You're just in the regular mode. Make sure you're using radians. You're going to put that in your calculator, and you're going to hit enter, and out is going to come an answer. Okay, that could be, maybe that's 0, or maybe that's -1. I don't know. But you're not graphing anything here. You're just putting the theta values in for theta and see what the outcome is for r. Then when it says plot the corresponding points, I'm not going to make you do that. You can take your graphing calculator and you can just graph the function and draw me a picture of what that graph would look like. For 3 through 6, this is an odd one because what you're really doing is trying to figure out what k would be. So it's more a matter of trial and error. So k is the maximum of theta in the window. And so you're just going to try some things. Maybe 2 pi is exactly the right amount to complete the graph. Give you a complete flower for the graph, or a rose. Maybe it was pi, so you're going to try some different values and see, just trial and error, how close you can get. Okay, and then you've got, it says exercises 7 and 8, you're going to refer to the curve. So for 7, you're going to just answer questions about that. You actually have 3 different equations, and you're going to see which one, if any, matches the one on the previous column. Then 9 through 12, you have some more graphs to compare with. Make sure you read the question carefully. 13 through 19, it says use the polar symmetry test to determine if it's symmetric about the x, the y, or the origin. For this one, you're certainly more than welcome to just graph it with your graphing calculator, and just by looking, determine its symmetry. If, however, you have a problem where you can't figure out whether it's symmetrical or not, then you need to use one of the symmetry tests. Okay, 21 and 23, you want to identify the maximum value, so that's where we actually put it in terms of x and y instead of r and theta, and found your maximum for your y. 25, 29, and 31, that's where you're going to do the analyze the graph and do the 7 parts of the analysis. Okay, have fun, help each other please, and I will be back on Thursday.